Okay, so I need you guys to remember polar quick. Yeah, this was kind of in vector land in trig. We're not going to do it with vectors right now. We're just going to do like, okay, this is polar.
Good.
So I think usually we plot points as x comma y's, right? What do I mean when I write x comma y?
Over X on Y.
Yeah, I mean go over x and then go up y. You guys all with me on that? Oh, and I'm kind of accidentally thinking vector land here again. You guys all see that?
Yeah.
That's totally okay. That's really kind of where I want you to be for points. So what's the other way to get to an x comma y?
You go up an angle and
Yeah, you go up an angle and then out. You guys see that? So that's going to be a theta kind of rotate, and then a, what do you call the other one? R. Perfect. Okay, so this is maybe the most confusing part, is that I'm going to think about x, y's as r comma thetas, and I'm not going to tell you in my writings here which one's which all the time. You guys remember that from trig class? Like this is another one of those things that's a little bit ambiguous, and you kind of have to sort it out from context.
something to mention.
Yeah.
The theta is always in radians.
Yeah, good. So unless otherwise specified, the theta is in radians. You guys with me on that? Okay, so this x comma y thing, that's called what? You guys remember that name? Yeah, Cartesian or rectangular. And r comma theta, that's polar. Cool, that's, when we get to Calc 3, we'll add another one. Right, because then we'll have an x, y, and a z, right? And we'll be able to do that as rectangular, or we can do polar in the x, y, and then add a height to it. Or we can do an angle off the x, an angle in the z, and a radius, which will be spherical. You guys cool with that? So there's a couple of these systems. I'm more attached to the idea that you guys know that there's more than one way to do this than attached to you having the specific words. But we'll use the words often enough that I think you'll get them. Cool? And yeah, Oven's point here is well taken. This thing is usually in radians. Some books will write things like 2, 0 degrees. Right, but they'll always put that little degree symbol in there if they intend you to use degrees. This is actually something we should talk about. Yeah, so that's 2 over and at an angle of 0, right? Okay, so if I was going to draw that, how else could I get there? Okay, so we should conjure up the conversion factors. I just want to highlight one thing here, which is that 2, 360 degrees, is that the same point or different?
Same. It's the same point, different angle.
That's the same point written with a different angle. You guys see that? Polar is a little ambiguous on points sometimes. You guys see that? Sometimes there's more than one way to get to the same point. That's not true in rectangular, but it is true in polar. What's the other one you have to watch out for?
Negative.
Yeah, so another way I could write this is I could go -2 at an angle of, at an angle of pi, or 180, right? You guys see that? You go over here, and then your radius points the wrong direction, so you go out, cool? Kind of out backwards. So usually this R, I'm going to force you to leave that positive. But the angle thing just doesn't go away. They're going to be a little ambiguous because you could always go a couple rotations around. The other one that gets weird is when the radius is 0, then the angle doesn't matter at all. You guys see that? Because it's always the origin. Okay, so there's a little bit of ambiguity here. Let's conjure those conversion factors out of someplace quick. They should be pretty chill. Where do you get r from?
It's the radius of a circle.
Yeah, it's the radius of the circle. It's also the hypotenuse of this triangle, right? Okay, so how do I get the hypotenuse of a triangle knowing the two sides?
X squared plus y squared.
So I need x squared plus y squared would be r squared. I want r, so I
Square root of x.
square root this. Cool. All right.
You have to worry about plus or minuses.
Do I have to worry about plus or minuses? This is what part of the reason for, I'm gonna force the r to be positive.
Okay.
Yeah, so I'm not gonna worry about plus or minuses here. I'm just gonna force the r to be positive. And then this one will take care of the plus or minus. So what's your angle theta? That's gonna be,
Is this
okay, so theta has something to do with the slope, right? You guys see that?
Inverse tangent or something?
Yeah, so kind of off to the side here, I'm thinking, okay, tangent of theta should be the what over what?
Y over x.
That should be the opposite over the adjacent, right? Y over x. So theta should be the,
Do inverse of y over x.
perfect, arctangent of y over x. You guys good with those?
I wrote the other stuff
Okay, so these two are the from rectangular to polar coordinates conversions. Where are the
down. X and y.
from polar to, yeah, so what's x in terms of r and theta?
R cosine.
R cosine theta? You guys all with that? Cosine of theta should be the adjacent side divided by the hypotenuse, then I multiplied by the hypotenuse, so I got just the adjacent side. So what should y be?
R sine.
R sine theta. Perfect. Cool. So if you guys want to throw these in your head and the picture, that would be perfect. Cool. Questions, Steels? All right.
What
Let's-
about from polar to reverse?
So these two are rectangular to polar, and these two are polar to rectangular. You guys see that? Like if I know an r and a theta, I plug those in, I get an x, and plug those in and get a y.